ERP Implementation. This is the fourth video in a series about implementation, and the first thing we're going to look at is forming a team, the Technical Support Organisation, or TSO. So why implement ERP as a kind of recap? Well, there's four reasons to do it. We want true business and application integration so that systems can work together and software can transmit information throughout perhaps a global business. We want superior decision support and other strategic reporting capabilities which ERP systems are very good at. An ability to fine-tune or completely revamp business processes, remodeling them in service-oriented architecture, which those business process ideas that we've put together are kept in a central repository, and for improved day-to-day operational reporting is another thing we want. So some not best implementation practices would include not willing to change the current business processes, not learning from mistakes, ignoring sound change control practices, lack of sound project management, relying too heavily on third-party consultants, lack of documentation, lack of executive level and functional area buy-in, and failing to deal and test adequately. So this is just a restatement of the benefits that we had before. First thing the ERP project needs is perhaps a name and a vision. So you can communicate that vision by showing what the realities of the budget will be, how it's going to be dealing with security, how it's going to be make it life more manageable, and how the system is going to be managed, how it's going to be available very often, and also scalable with the growth of the business, and how it will meet business needs. So to get that vision across, you have a steering committee, and the steering committee consists of a chair. There will be a project sponsor, if not the chair, then someone assigned. A director of enterprise computing, the senior SAP solution architect if it's an SAP project, company internal project managers, the CIO or their designate at that level of the company, and managers from functional areas or their delegates. So we want to get over to all these people how this project's going to improve the way the company operates. That's very important at the beginning. So that's where the vision comes in. Now the TSO, or the Technical Support Organisation, it will include specialists in SAP Basis, that's the underlying web server supporting ERP, the databases where the data is stored, operating systems and the hardware that runs all these systems, the servers and storage, and there'll be data center experts as well who can provide the kind of monitoring and also battery backup and resiliency and that kind of thing. So in this image on the right, you've got the solution stack. So these are all pieces of software and hardware that are going to be implemented in different parts of the business, and you can see them identified in the grey shapes on the right. These are all areas that will need to be put in place. On the left hand side here you can see that there are against the different components there will be various people involved. So in that green rectangle there it says SAP Data Center Lead, so they'll be responsible for those areas. There'll be a database administrator looking at the database layer, etc. There'll be a SAP Infrastructure and Basis Lead looking at the database and how that links to the I/O graphical user interface, and how that works in between, which we can look at later. And there will be a solution architect responsible overall for all of those things and how they go together. So in a bit more clear fashion, in the yellow window you've got the SAP functional team and the infrastructure team, and one looks at the different functions and business processes, and the other one looks at the underlying technical basis of an SAP project. So, implementation, the elements of an ERP rollout. Well, the relevant phases of an ERP project are implementation, operation, maintenance, and the upgrading after between 5 and 7 years, typically 5. And SAP call this the SAP implementation cycle. Project preparation, plan the project, set up implementation standards, have a kick-off meeting to kick the project off, system setup, production hardware installation, quality check, and project preparation. And that is the start. That's after the start, and you have the kick-off into blueprinting, where the system is designed. Then in the realization phase, it's where you start to make sure that everything works, and then planning for how you're going to cut over to that new system and how that's going to happen. So you might have parallel running, you might have consultants involved, etc. There'll be final preparation, where you refine your cutover plans, which is your switching on the system to the users just before go live. And then there's go live support. Implementation duration. Well, this will depend on the extent of the customization of the software, the project scope, resources devoted to the project, the size and complexity of the organization, and the caliber of the implementation team. So all of those matter, and you need to get them right. Typical time per stage of an ERP project: the preparation phase about 11%, business blueprinting 14%, the realization at 50%, which isn't unexpected, final preparation 19%, and go live and after support 6%. So those are the kind of things that are involved. Planning the elements that need implementation is key. So on the right hand side here, you can see that there are two threads to this. You set up a technical sandbox and a business sandbox, and you work out how the business processes work, and you thrash out basically how the new company is meant to work. And then, and I say new company in terms of it's a new company because it's running a completely different system. And then you have the development phase. You test it and put some quality checks in place, and then after that you're ready to train the employees. You can put the system on a staging system and then a production system, and you might also have a disaster recovery live site if it was a really mission critical system that always had to be up. Otherwise you can use virtualization to do disaster recovery. On the left hand side here, you've got the various elements in the project. So there'll be functions, ERP functions in this case, interfaces design, IT infrastructure to put in place, data conversion and management, reporting to be set up, and the project organization and how it fits with the actual organization. Then you have the installation stage. So implementation starts off with installation, where you actually put in the software and hardware. So what's that? The mechanics of changing software versions or a new package. Successful installation doesn't ensure successful implementation. You can come a cropper having put the system in and installed it very nicely, as Nestle found in one of the case studies. It may not achieve the company goals over a period. Nestle started their implementation as an installation project. Only then did they realise that it was actually the need for change management that was key to success. So if you put in software and then the staff don't know how to use it, then that's going to lead to poor results. Use of a sandbox version. So you might have a development instance of the ERP system that's going to go in, and you try things out. and you can also use it to replicate faults that you keep finding at the beginning. ERP experts say a central instance should be the route chosen, so you really want it to be available to everyone. Otherwise, a second business process re-engineering project may be needed in the future. Well, that may not be a bad thing. It may be possible to do a certain amount now and then a certain amount in the future. The benefits of business intelligence and online analytical processing for global businesses drive centralization. So that's what the project is about. It's to bring the data together and to allow you to do meaningful investigations on the data. That's one of the benefits that's going to come from the project. Configuration inputs, company policies and settings need to be put to the software so that it follows the way that the company works. Customization actually modifies the software and processes. So customization will modify things, and that modification will become problematic when you want to go to the next version. But a lot of companies do it to a certain extent. The installation and hardware. So the installation process, you either rent or you install a data center space, which is air conditioned. It's got battery backup and all that kind of services provided to it, power of course. And so here are a couple of instances of different service centers, clusters, where you might have your ERP systems working. Often the case that new hardware will be needed to run such infrastructure. You could outsource installation, so you could have outside people do the that and put it into one of their data centers. So your company's core competency is still retained, but you're actually using somebody else's facilities to run the software and hardware up, and that can work, but it can lead to more costs than you're expecting, so you won't save as much as you thought you might, but it does give more flexibility. And we talked about cloud computing previously, so you'll have some idea of that. ASP implementation. So this is the installation considerations. This is where an application service provider is doing the system for you. It's based on a pre-configured solution, so if you went for SAP Business by Design, you'd get very much a pre-configured solution without much customization possible. You'd have a scoping phase to discover the client need for application software, hardware and delivery method. A user per month price based on client needs, best suited to small to mid-sized clients and those who want a turnkey solution for ERP, supply chain management and e-business packages. 1,000 user company can save up to 17% by using this kind of system over 5 years if it's done well. So installing the infrastructure, there'll be a need for switches, an application server, firewall, and you'll have a number of different sections to the firewall. Sometimes you have double firewall with a demilitarized zone in the middle to make it more difficult for people to just idly come into your site, and that will all feed into a database server, and you can put all that in a rack as you see in the diagram there. So multi-tiered hardware needed may require new hardware systems, which almost certainly will do. And you want to size the system. So how do you know it's going to do enough transactions per second? How do you know what hardware to put in? How do you know how that's going to work? Well, there is a sizing system that enables you to look at the hardware sizing, the business requirements, come up with there is something called an SAP Quick Sizer where you can answer questions and put those into a method of getting your results and turning them into the sizes required for the system, and you can communicate that to your hardware partner. The diagram on the left here shows sample server platforms, so different server platforms there, and then how many SAPs required, so SAP systems, how many you'll need, and that will include CPU type. You can record that, and then you can work out how much processing can be done by each CPU, and then the maximum number of CPUs you need to process the number of transactions. So in this case, it's anything up to 10 CPUs can be used, and that will allow this number of SAP S's to be processed. So in maximum 34590. It's very important to make sure that you've calculated the number of transactions per hour that you're going to need to be able to process, and make sure the system can do it. Then you have system sizing. So this was an image I took when we were looking at my SAP CRM and all the other different functions, very similar to now, but they've dropped the my part and just call it SAP CRM, SCM, ERP, etc. In the diagram on the right, there are some actual configurations of servers and how they're connected up and what backup facilities they have for a particular project in the past. So you have a primary data center on the left and disaster recovery data center on the right, although, as I said before, this could be virtualized. You want to mitigate single point of failure in networks and anywhere really. So it's important that any risk of a single point of failure is mitigated by, in the case of networks, to have dual network cards, if it's servers, to have dual servers, dual storage devices, etc. So you eliminate single points of failure which could happen and strike you down at any particular point. So there are various ways that you could also, through the use of RAID drives and that kind of thing, have reduce the failures that could happen. So if you have a RAID 5, then you can have one disk go down and still, or whatever it happens to be, it could be a solid state drive. If one fails, you've still got all the data. There are other RAID array formats. Sometimes it can allow you to have 2 disks go down and still have all your data. Then the system would flag you up that there was a disk needing replacement. You have hot pluggable disk drives, so it's just easy. We don't have to shut the system down. You can just take one disk out, put the other one in, and then over a period that disk is brought up to speed and has the right data on it. You also can prevent problems from having a server go down by having server clusters and have them replicated to a second site, so that there is always you can either do it by mirroring, so you can mirror real-time data through to another data center somewhere else. Very important to do that. In the World Trade Center, you had some firms went out of business straight away who were trading solely in the World Trade Center. There were others that were replicating their data to somewhere else in New York, and unfortunately for them, the dust cloud from the building falling down when the World Trade Center was hit by the aeroplane or airplanes clogged the filters of the generators that brought the power back on in those buildings, and they failed. The companies that were left trading and didn't lose much data were those that were mirroring in real time to a remote site where you might have another data center. So server clustering and data mirroring, very important, especially for financial transactions where you're trading millions of pounds worth of shares at any particular time. There's an additional uptime via server clustering and data center failover. So you can have different nodes. When one node fails, another one takes over automatically, so you can automate this disaster recovery process to a certain extent. You can also have a complete remote and redundant data center for disaster recovery, and that illustration on the right shows that. You can also go through, and need to go through, a process of rating your data center partners, and you can look at the high cost of downtime as well. So the first thing is to basically rank each of your technology suppliers, those who are going to provide you with data center support and services. And so you can write down some technology, services, consulting and business practices elements to work out an overall score. In this case, you can see that Hewlett-Packard came out on top, beating IBM and Sun. So it's quite a big advantage in that respect. That would help you in knowing who were the right people to be involved with your project. Losses from unplanned downtime. You might have unplanned outages per year that is showing 13.13 might happen per year. Average duration per outage 4 hours. The average revenue loss per hour of planned outage 160,000. So an average revenue loss per unplanned downtime event is about $640,000, and an average annual revenue loss from unplanned downtime of 8.4 million. So you can see this kind of downtime needs to be eliminated. It's good not to go overboard though, because you can because there is a law of diminishing returns. So if you look at the diagram on the left, if you set a 99.9% availability, you'll be paying X dollars to have that. If you go for 99.99, you're going to pay 3 times as much. But if you go for 99.999, you're paying 12 times as much. It makes an enormous difference to the amount of money you're going to be spending out. And depending on what type of industry you're in, will determine which of those you decide to go with. So obviously financial data that's real-time data needs to have much higher availability and will pay a higher cost. You put in redundant power supplies, so up to 4 I guess. You have duplicate breaker panels, duplicate cabling, duplicate switchgear, and then in the generator you'll have a main utility company power source, but you'll also have a backup generator you can switch over if the mains fails. Very similar to what they've got in SAP data centers. You'll need cooling, so you're either passing water around the system and having it cooled through that which takes the hot air away by exchanging it through a heat exchanger, and then driving it off to atmosphere from coolers on the roof. Sometimes they spray water onto the fins, adiabatic cooling. What there is remarkably little of at the moment are server cards that allow the main processor to be water cooled. It would be very complex to do it, but on the other hand the efficiency would be so much higher than using just ordinary cooling. So here's the solution stack, which we covered a little bit earlier, and that's all housed in some of these racks, which you'll have seen in data centers, around the world. Application servers. In this diagram, and I wouldn't expect you to understand or remember this at any assessment, but there are a number of areas. So you have an integration repository with mappings, interfaces and components. We talked a little bit about integration in one of the earlier lectures. You have an integration directory that's got rules, mappings, services, etc., and knows the landscape, and that feeds into an integration engine which links or provides information to existing SAP applications, third-party enterprise applications and legacy ones through a series of adapters. So for example, RFC doc adapter, they go to your application servers. Here we've got the databases. So while there are multiple applications in an SAP system, there's one database server feeding them with the cover they need, and that typically now is a SAP HANA database because of the speed of it, what it can do for getting results quickly once a query is launched. So you've got application servers, and they're being fed via a part of the database for supplier relationship management, etc. So lots of different application servers linked up to that particular function. So accessing ERP, an overview of the process. This is a few steps. So here we've got the user enters input through the SAP graphical user interface or a web browser, something like that. The input may be either information to be written into a database or a request for information or a calculation. So the next step is the input goes over the network via TCP IP, Transmission Control Protocol, Internet Protocol, to the SAP application server and is handled by the SAP dispatcher, which is a routine which is handling work. A software component that functions as a central control unit is how I put it there. So that chunks the work into packages which can be done. Within each application server there's a single SAP dispatcher which handles all user requests as well as requests from other application servers. This dispatcher assigns requests to different work processes. The data then returns to the users. Each work process opens an individual dialog to the required database. Responses from the work process returned by the same path through the dispatcher of the SAP application server and back to the user. So that's how that works. I just thought I'd show you, I'll talk a little bit about SAP and the Technical University of Munich, and those photographs in the bottom right of the picture show the Technical University of Munich and some of its quite large buildings, including their service centre. On the left hand side is a typical SAP UK training course if you go on a physical one. This is kind of the number that will be there at any particular day, and where it's going. So that's the end of that briefing. That was ERP Implementation Overview. That covers some of the hardware, software considerations and planning, installation, etc. that you have to think about to make a good implementation. We haven't talked about change management too much in there, but it's obviously a very important subject in that. So thank you very much, and a future video will look further into this.